Now we shall go into the topic 7.2. The topic is redox and electron transfer. Electron transfer. See, the concept of redox reactions. I already told you the redox reactions are, the redox reactions. It is a concurrent occurrence. It is the simultaneous occurrence of oxidation as well as reduction, right? So you are very familiar with that. We will see one reaction belong to the particular category. See, for example, let's see how the magnesium is reacting with the oxygen. So if magnesium is reacting with oxygen, it is going to form Mg2 MgO. So this is the reaction it is going to follow. If you look closely into the reactions, let's see what is happening to magnesium. Let's see what is happening to oxygen. If you write the half cell reactions, if you write the half cell reactions, you will have a clear picture how the magnesium, what shall happen to the magnesium, what shall happen to the oxygen. See here, magnesium, it is actually, it is losing 2 electrons, so that, it is becoming Mg2 plus 2 electron. Okay, so it is losing 2 electrons. So why it is losing 2 electron? Because magnesium, it got a 2 as the electronic configuration. When it is trying to lose 2 electron, like a 2 electron if it is losing. So this magnesium 2 plus, it is going to have a 2 So there is only 8 electrons in the outermost shell. Okay, and where does this 2 electron will go? So obviously this 2 electron is going to getting accepted by oxygen. So we shall see how the oxygen it is coming. We can see how, I will write the next half cell reaction here. Oxygen, it is going to accept 2 electrons, so it is going to become O2 minus. If you look internally, what is happening to the electronic configuration of oxygen? Here it is 2, 6, because the atomic number of oxygen it is 8. So its electronic configuration is going to be 2, 6. When it is gaining 2 electrons, its electronic configuration shall changes into 2, 8. So here oxygen is also gaining 8 electrons in the outermost shell. It is happy. Okay. So the condition of octet, that means 8 electrons in the outermost shell, is met for oxygen as well as magnesium. Okay, magnesium as well as oxygen. And if I draw its electronic configuration in a shell manner, so I can write in this way. See, this is this is magnesium, because it got 2 shells, 1, 2, 3, 4, 5, 6, 7, 8. So this 2 electron. So this is oxygen. So this electron and this electron will go to oxygen. Got 1, 2, 3, 4, 5, 6. This electron and this electron will go to the L shell. Here actually it got K, L, M. Here actually oxygen got K and L. So it will go to the L shell of oxygen. Okay, and oxygen will be having 8 electrons in the outermost shell. It is happy. Now, next very important thing, we need to see, we need to balance. We will check this oxidation reduction reaction. So this is in fact loss of electron, right? Loss of electron. So we will write. We will tell one more definition for oxidation and reduction. Please remember, this is nothing but magnesium. In case of magnesium, it is losing electron. So magnesium got oxidized. Magnesium, please remember, loss of electron is oxidation. Here actually oxidation happened to the magnesium. Here oxygen, it gained 2 electrons. So this is actually gaining of electron. This is actually reduction. So if I write a simple code, please remember, if I write a simple code, you can just go from oil rig, O-I-L-R-I-G, oil rig. Okay, I will write here. Sorry, I will write here. Oil rig, O-I-L-R-I-G. Okay, so oxidation is loss of electron. R stands for reduction is gain of electrons. Okay, oxidation is loss of electrons and reduction is nothing but the gain of electrons. Please remember this. Now, here one very important thing, these redox reactions and oxidation reactions, it is not much balanced. We need to balance it. This balancing of oxidation reduction reactions are very crucial for a reaction. We shall use this space. Okay. Yeah, I will write oxidation reaction here. Mg gives 2 electron. Oxygen, it is accepting 2 electrons, so it is going to be O2 minus. Okay. Yeah, here it is. There is no issue because magnesium it is just a metal and there is no issue here. This is okay. But here we need to know. Do you know any species like O is existing? No. Oxygen always exists as a molecule, except in rare cases when some singlet oxygen is forming. So oxygen, this is not a balanced one. So we need to balance it. So if I put a 2, if I just multiply everything by 2, so then actually this is going to be 2, this is 2 into 2, this is actually 2 into 2. So I can write O2 plus 4 electron minus, this is actually 2 O2 minus. Now this is balanced. Okay, but when this is balanced, actually here 4 electrons are there, right? Here it is not balanced. Here only 2 electrons are there. So here also I will multiply with the 2. I will just write the reaction here. Let's see combined one. So just this is 2 Mg plus 2 Mg gives 2 Mg2 plus 4 electrons. This is oxidation half cell reaction and reduction half cell reaction. So O2 plus 4 electron gives 2 O2 minus. Okay. So if you just do the calculations, so you can cancel this, you can cancel this. If you are adding both, if you are adding this 1 and 2, if you are adding both, you can cancel both. So this is going to be 2 Mg plus O2 gives 2 Mg2 plus 2 Mg2 plus this one will come 2 O2 minus. Okay, so this is how the reaction it is happening, and please remember that oxidation, better definition is oxidation is the loss of electrons, reduction is gain of electrons. Okay, so this is what it is. Please remember this particular thing from this this example. Okay, I have seen the example of magnesium oxide. So now the definition of oxidation and reduction, it is much broader now. Earlier we just said that okay, oxidation is acceptance of oxygen and reduction it is the loss of oxygen, or in terms of hydrogen we said okay, oxidation is a loss of hydrogen, reduction is a gain of hydrogen. But now the definition of redox reactions are much broader. Redox reactions are exchange of electrons. If any exchange of electrons are happening, that is called a redox reactions. It doesn't need to include oxygen. For example, we will see one or two examples again. See, consider the case of sodium chloride, Na plus Cl2. This is going to give a 2 NaCl. So this is a redox reaction, right? Now in the previous example, same like a previous example, we will split its oxidation half cell and reduction half cell. 2 NaC, this is going to give 2 Na plus 2 electrons. Okay, and yeah, because you know very well sodium is having electronic configuration 2, 8, 1, because atomic number is 11. When it is losing one electron, this is going to become 2, 8. So there is only 8 electrons in the outermost shell. So it is happy. Sodium is happy because once it is losing one electron. Now you see the example of chlorine. Cl2, Cl2 plus 2 electron. This gives 2 Cl minus. Cl2 actually it is so this is how it is coming, right? Now why 2 Cl minus? Actually chlorine it is going to have 2, 8, 7 in the outermost shell. When it is accepting one electron, it is going to become 2, 8, 8. So Cl minus is going to have 2, 8, 8 electronic configurations are there. So as you are aware, here the loss of electrons are happening. So sodium got oxidized, right? So this is the oxidation. This is the gain of electrons are happening. Gain of electrons are happening. Now we will just combine this oxidation and the reduction half cell reaction to see the redox reaction. See, okay, we will just combine 2Na gives 2Na plus 2 electron, and here actually Cl2 plus 2 electron gives 2 Cl minus. Okay, we will add it. We will add both of these reactions. Okay, so here actually sorry, I will just write it here. That is better. So here it is 2Na gives 2Na plus 2 electron, and here actually Cl2 plus 2 electron, it gives 2 Cl minus. So we can just we will see how we can cancel. Here actually 2 electron because it is in the product side. This in the reduction half cell, it is in the reactant side, so we can immediately cancel. And then if we are adding 2Na plus Cl2 gives 2Na plus 2 Cl minus. This is going to be the redox reaction. Okay, so here actually sodium got oxidized, and chlorine it got reduced. Now next reaction we can see. Next reaction, if you are looking into the next reaction, okay, here let it be Cl2 plus 2 KBr. This gives 2 KCl plus Br2. Do you know one thing? When this reaction is happening, when this reaction is suppose you are just in the start of the reaction. Think that just in the start of the reaction. So in the start of the reaction, this beaker it is going to have chlorine. This is going to have 2 KBr, right? You may be there are KBr crystals or KBr solution. You may be passing chlorine through that. So initially this solution it is going to be colorless. So but once the reaction goes on happening, okay, so due to the presence of this bromine, okay, bromine, this solution, this is going to change into brown color, reddish brown color, because bromine it is a reddish brown solution. Okay, now let us see how the reaction is, how the half cell reaction of this one is coming. Okay, we can write the half cell reactions of this. See here actually chlorine. See, very well you are well aware. In fact, what is happening to the KBr, potassium bromide, it is getting converted to 2 KCl, right? So here in fact bromine Br minus is here in fact Br minus is 2 Br minus, it is getting converted to Br2. And now Cl2, here in fact Cl2 is there, right? Cl2 is getting converted to here in fact Cl minus, right? So 2 Cl minus. So this is what is happening. Here this reaction, this is nothing but it is losing 2 electron. So this I did insert 2 electrons, right? So I will just write properly. Plus 2 electron, it is going to give 2 Cl minus. Here it has lost, Br minus has lost electron. So this is going to be oxidation. This is going to be oxidation. And Cl2, this has gained electron, so this is going to be reduction. Please remember one thing, when this reaction is proceeding, here this bromine, the color will changes into reddish brown due to the presence of, due to the liberation of bromine. Now, for getting the redox reaction, total overall redox reaction, we will just combine these two reactions. So this one and first one and second one, I mean oxidation half cell reaction and the reduction half cell reaction. Okay, so we will see. Anyway, we doesn't need to write it separately, it's already here, so we will see it. So here I will just add 2Br minus. So yeah, 2Br minus, wonderful. Yeah, Cl2 plus Cl2, and this 2 electron get cancelled out of this 2 electron, because this is in the reduction half cell, it is in the reactant side. Oxidation half cell, it is in the product side. 2 electron it will cancel. Okay, if it is 4 electron, we need to balance. Yeah, now what is in the product side? Br2. Wow, now 2Cl minus. Okay, so this is how it is coming. So this is the overall redox and oxidation reactions of this particular reaction. Cl2 plus 2KBr gives 2KCl plus Br2. In this particular unit, in this segment, please remember the core concept, that is oxidation loss, reduction gain. So oxidation is a loss of electron and reduction is a gain of electrons. Okay, so this is what you need to know. Yeah.